Have you ever wondered how a silent, lifeless box can suddenly fill a room with your favorite song? How does a simple wire, carrying nothing but invisible electricity, create every note, every beat, and every word you hear? We are surrounded by speakers. They are in our phones, our laptops, our televisions, and our headphones. We press a button and sound just happens. It feels like magic, but it's actually a beautiful piece of science and engineering. From the tiny speaker in your earbuds to the giant stacks at a concert, they all work on the exact same fundamental principle. To understand it, we need to follow the journey of a sound from a digital file all the way to your eardrum. The core challenge is simple but huge. How do you convert one form of energy into another? Specifically, how do you change electrical energy, which flows silently through wires, into sound energy, which travels as waves through the air? The sound of a guitar strum or a singer's voice doesn't travel through the headphone cable. So what does? The answer is a signal, an electrical recipe that tells the speaker what to do. Your music starts as digital information, a series of ones and zeros on your device. When you press play, your device converts this digital code into a flowing electrical current. Think of it as a rapidly changing electrical message. This electrical signal is not sound itself. It's a set of instructions for how to create the sound. This signal now travels down the wire to the speaker. Inside every speaker, you'll find three key parts: a permanent magnet, a coil of wire, and a cone. Let's focus on that coil of wire. When electricity flows through a wire, it creates a small magnetic field around it. By wrapping the wire into a tight coil, we can make that magnetic field much stronger. This turns the coil into a special kind of magnet called an electromagnet. Unlike a regular fridge magnet, an electromagnet can be turned on and off just by controlling the electricity. Not only that, but we can also flip its north and south poles just by changing the direction of the electrical current. This is the secret. The permanent magnet. This magnet is fixed in place inside the speaker, right next to the coil. You know what happens when you bring two magnets together. Opposites attract, and like poles repel. They push or pull on each other. The speaker uses this simple push and pull force to create motion. The electrical signal from your music is constantly changing. It flows back and forth through the wire coil hundreds or thousands of times per second. As the current changes, the electromagnet's poles flip back and forth, over and over again. This causes it to be rapidly pushed away from and pulled toward the permanent magnet. It starts to vibrate, moving back and forth very quickly. The rhythm and speed of this vibration perfectly match the electrical signal sent from your device. This is where the last part comes in, the cone. The vibrating voice coil is attached to this cone, which is often made of paper or plastic. As the coil moves back and forth, the cone moves with it, like a tiny piston. This moving cone pushes and pulls on the air molecules in front of it. It creates areas of high and low pressure. These ripples of pressure are what we call sound waves. They travel through the air, away from the speaker. When these waves reach your ears, your eardrum vibrates in the exact same pattern, and your brain interprets this as music, a voice, or a sound effect. So a speaker is really a translator. It translates the language of electricity into the language of sound waves. The entire complex world of audio, from a whisper to a roar, is built on one simple scientific principle: using electricity to create a magnetic force. The next time you listen to your favorite song, remember the invisible dance of magnets and electricity happening thousands of times a second, just to bring that sound to you.